Good afternoon, everybody. Thank you for coming to our session. Today, we're going to talk about what's new with Amazon DocumentDB. Super excited to be here. My name is Rishim Gupta. I lead the product management team in DocumentDB. And with me is Win Yu. He's a senior product manager in DocumentDB. Here's the agenda for today. Actually, before I start, show of hands, how many of you use DocumentDB today? Quite a few of you. Great. So here's the agenda for today. I'll spend about 5 to 10 minutes covering an overview of Amazon DocumentDB. I'll go over what Amazon DocumentDB is, why we use it, how our customers use it. And then I'll hand it off to Win, who will talk about what's new, especially what we've launched in 2022. And then he'll do a deep dive on Amazon DocumentDB Elastic Clusters. That was an announcement this morning in Swami's keynote. And along the way, we'll have some demos. So let's dive right in. So to the overview. So what is Amazon DocumentDB? Amazon DocumentDB is a scalable, highly durable, and fully managed database service for operating your mission-critical MongoDB API-based workloads. So what does that mean? Let's dive deeper into each of the 3 characteristics called out here. So let's start with scalability. So I would say there are 3 things about scalability. Firstly, DocumentDB's architecture is such that we built it such that compute and storage scale independently of each other. So that gives you a few benefits. Firstly, you can scale your compute within minutes. And you can also, in terms of scaling your storage, it is auto-scaling. So depending on how much storage you use, the storage auto-scales. So this makes it very fast. Secondly, a DocumentDB cluster has up to 15, you can have 15 read replicas. So what that means is you get high I/O throughput. DocumentDB already supports millions of reads of IOs today, and with today's announcement on Elastic Clusters, we also will support millions of writes, and that's something Win will talk about in his presentation. Finally, DocumentDB also supports multi-region use cases with a feature called global clusters. With global clusters, you can have a primary cluster in one region and secondary cluster in other regions. So this is very useful for scenarios like high availability and disaster recovery, where you might want to fail over from one region to another, or if you have like a global application with low latency requirements, and you have a need to read from the closest secondary cluster in a different region. So that's on scalability. Let's look into fully managed. What fully managed means is we take care of all the administrative tasks for your DocumentDB cluster. So each compute and storage in your cluster is spread across 3 AZs by default, giving you high availability and high durability. We take care of things like backup, patching, and security best practices, so you do not have to worry about that. We also are integrated with CloudWatch, ensuring that you get automated monitoring and alerting. Now let's look at MongoDB API compatibility. DocumentDB has wire protocol compatibility with MongoDB API. What that means for you is you can use your same application code, same drivers, same tools, and with little to no code change when using DocumentDB. We support hundreds of operators and APIs and continue to invest in it based on customer feedback. And we'll talk about a lot of them in this presentation. So when should you use DocumentDB or a document database? DocumentDB is a good fit if you have the need to store, query, and index your JSON data. Another indicator for a good fit for DocumentDB is if you have a flexible schema and you want to iterate fast on it. So if you either do not know your schema or you know your schema will evolve, DocumentDB is a good choice. DocumentDB also enables you to do ad hoc querying and flexible indexing over, again, a schema that may change. For example, we support geospatial indexes, we support multi-key indexes, which support a variety of use cases. Finally, DocumentDB is good not just for your operational workloads, but also your analytic workloads. We support group buys, summation, aggregation. We also have a JDBC driver that you can connect for your analytical tools. So let me give you an example of, to put all these things in perspective. Let's say we have a gaming application, and you have a customer profile JSON object. And let's say we have a gamer by the name of Anna, and we have her information stored in this JSON object for user profile JSON, right? And let's say we launch a new game called Exploding Snails. So we launched this game. Anna starts playing it, and she reaches a certain level. She has a score. And we decide, OK, now we want to save that. We want to save the user state as well. So in any other database, relational database, you may have to create like a table and define a new schema. With DocumentDB, you don't have to do that. You can just save the user state in the same object, and your application will still continue to work. Down the road, you can change your application and deploy new code if you want to access the user state, again, without changing the underlying storage and schema. So that makes it very easy and fast for you to iterate and continue to build your application. Here are some more examples of customers using DocumentDB. DocumentDB is used in web publishing industry. Customers like BBC and Washington Post use DocumentDB for their online news website. Retail is a very popular sector for customers to use DocumentDB because retail customers have a lot of product catalog. So Woot.com, Amazon.com as well for like the third-party seller, they use DocumentDB to store the product catalog. It's actually a good fit because if you can imagine there are millions of products out there, each product has different types of attributes. And so you don't have to keep creating different schema for all of them, but you can just store them in this flexible schema model. DocumentDB is used by many financial customers. FINRA uses it for regulatory documents. Capital One uses DocumentDB for their card management business. Tomorrow, there's actually a presentation by Capital One tomorrow talking about how they use DocumentDB. You might be interested in that one. Finally, gaming. We continue to see more and more gaming customers use DocumentDB for saving user profiles, user state, as well as in-store transactions. DocumentDB is actively used by tens of thousands of customers today, and here's a list of some of them. What you'll find is customers of various industry segments, various sizes, and different geographies use DocumentDB. What we're increasingly seeing, customers who have any kind of use case in database use cases do find DocumentDB to be very successful for their workloads. DocumentDB launched in 2019, and in the last 3.5 years, we've continued to innovate on behalf of our customers. Here's a list of the features and operators APIs that we have launched. I don't have time to go through all of this, but I'm going to hand it off to Vin, who will take over and talk about what we've launched in 2022 and beyond.
Hello. Thank you, Rashim. Really good recap there that he just provided. And one of the things, so I'm moving on to the slide. So one of the, speaking of customers that Rashim was just showing you, actually that slide that he was showing with all those customers, each one of those customers, if you go to our documentation page, you'll actually see use cases of what each and every one of those customers is actually using DocumentDB for. And it's always good to hear about how customers are using our product and even actually partnering with us to build a better product. And as Rashim mentioned, there is a session tomorrow where Capital One's could be sharing some stories on how they use AWS and DocumentDB to build the next generation platform. So my name is Vin. I'm one of the product managers of DocumentDB, and I will be sharing with you what's new in 2022. All right, so the first thing I want to be sharing with you all is the availability of new instances and regions of DocumentDB. So the first thing we did was we actually made Graviton2 instances available in all regions where DocumentDB can be deployed today. So two main benefits on why you might want to be using Graviton2 instances. One, performance. It's actually up to 30% better performance compared to R5 instances. The second is also cheaper. So not only is it better, it's actually cheaper. We actually charge 5% less compared to R5s. So if you already have a DocumentDB instance and you're using R5s but not using R6s, super encourage you all to give this a go. And the second is region launches. We also made DocumentDB available in Milan, Italy, and Beijing, China. Previous to this, we were available in 4 regions in Europe and only 1 region in China. But now we're available in these additional regions as well. So if you have an application that has a need to run in these regions, you can now run it there. All right, let's dive deep into the query capabilities that we launched this year. So as Rashim mentioned, well, one of the benefits of DocumentDB is that we have the ability to index on many different things. One of them that we've launched this year is geospatial indexes. And this is really good for any time you're dealing with location data. For example, maybe your app has the question, you might ask the question, well, where's the 10 closest restaurants to the Venetian, to this very location? Or how many people are on site? And that's a geotagging example, where you can ask that where you could use geospatial indexes to help you determine the answer to those questions. Second, a little bit more on the technical side, aggregation operators. We introduced 2 operators here. I'd like to call out merge objects, which merges multiple objects, hence the name, and also reduce, which reduces multiple fields into one, hence reduce. And the last thing I'd like to call out in terms of query capabilities that we launched this year was decimal 128. Now, anytime you are dealing with decimal data, decimal numbers, for example, taxes, finances, accounting, or scientific applications, you're going to want to ensure that your decimal values are being processed accurately, because those pennies do add up. Okay, and I know I'm speeding through this because I'm just super excited to actually jump into the Elastic Cluster section, which is we just announced hours earlier before the session. So by zooming back in, enterprise management features. First I want to talk about is dynamic volume resizing. As Rishir mentioned, we have a separation of compute and storage. And what this really means is that you can add more storage or more compute without interfering with the other. That is, you can increase your storage capacity without adding more instances. You can increase your compute capacity without having to add unnecessary and unused storage. You don't have to do this up front. With dynamic volume resizing, when you delete data, with whether you're deleting a collection or deleting an index, we're also now going to shrink that storage cap, which helps you save on costs. And this is done automatically. So you don't have to turn that one on. Second is fast database cloning. This is a feature that's going to enable you to clone your database in pretty much constant time. Whether you have a 10 gigabyte database or a 40 terabyte database, we can actually pretty much clone it at the time it takes to create a new instance. Now, why might you want to create this clone? 2 reasons, really, I would say, as an example. One, maybe you want to test changes from one environment to another, for example, production. Let's say you want to add a new index, or you want to change some configuration settings. You don't want to apply it directly to your production environment right away. One way you could do this is to clone your production environment, then make some changes to test it out, to see if it really works for you, then apply that change to production. Second is running analytical workloads. For example, let's say you want to run a report at the end of the week or the end of the month. You don't want to add more load to your production environment than you already have. So you can clone your database, and this is going to be very useful for those type of scenarios as well. Third here I'd like to call out is is query auditing, now with DML capabilities as well. So this is going to enable you to capture and log any time a user makes any activity on the database. For example, Betty and John, they have access to your database. You want to make sure Betty and John as users, you want to log the trail of what records or documents are they retrieving, what documents are they making edits to, what schema changes are they necessarily making on the instance. Query auditing is going to enable you to capture all those things. Very useful, I would say, from what we've seen in customers. If you're in finance or healthcare, typically you may need you need some form of auditing in place, and this is going to help with that. And last but not least, not to play favorites, but it's almost pretty much one of my favorite features is performance insights. If you are using performance insights in, say, Aurora, very similar feature, 2 main things. When was there a load on your database? And what and where is it coming from? Really useful. And I want to say this is not just it's not just a monitoring tool. It's actually a complete monitoring package. And what I mean by that is performance insights, when you turn it on, it's going to do 3 major things. 1, it's going to gather your data. So it's going to continuously gather data from your instances. 2, it's going to store that data for you. And 3, it's going to help you provide the visualization so that you can actually visualize when and where there was a challenge. And actually, the biggest thing about all of this is it's free. If you're in front of your laptop right now and you're using DocumentDB, go to the portal, click a button, and turn this on. Free of charge, we store up to 7 days of your data, performance data, for you, and you can go and view that in a bit. Let's dive a little deeper. When you are typically monitoring your system and you might see a challenge, some of the questions you might have is, well, where was there unexpected load on my database? Well, which queries are causing a lot of load on my database? Which clients are causing a lot of CPU or high network? All these type of questions can be achieved and answered from Performance Insights. Let's go take a look at that. So here I have a dashboard. This is a view of Performance Insights. There's a lot going on, but let me walk you through it. In the middle of the page, you're going to see a graph. And what that is it dictates database load. So here, you can see the load of my database. Pretty much, it tells me how many active queries are running against my database at any given time. First question is, when? This answers it immediately. Right in the center of the page, you can set the time frame as far as 7 days, and you can zoom in down to the minute of when there's load on your database. So here as an example, I have this sliced by application, which means I want to know where the load is coming per application. Here, you can see at some given point, kind of small, I think it's 8:17. You can see that there's a new app that entered the room, Meet app, producing more load. If this is unintended, you can go here and trace that down and close those connections and close that app. Beyond that, you can take it a step further. Let's say I want to know the exact query from that app that's causing load on my database at those certain times. That's possible. You can see the top weights, which is how much CPU or I/O or storage or memory it's consuming. You can also see how much or which queries or which host this is coming from. So here, I'm able to take a look at the top queries that's impacting my database by application. Really powerful stuff. And again, if you haven't used this yet, turn it on for your existing instances. All right. 2 elastic clusters. Woo! Okay, show of hands. Who was actually in Swami's keynote this morning and heard of this feature? A few. All right, there's some folks that haven't. It is Vegas. Maybe you were up late last night. It's fun. But for those who missed this, elastic clusters enables you to scale your document database workloads beyond the limits of what DocumentDB offers today. To the point of what Swami was mentioning, really future-proofing ourselves. And I want to explain to you how much are we going beyond. So in this section, I'm just going to recap on why elastic clusters, why might you want to use elastic clusters, horizontal scaling, sharding, those type of things. Then we're going to go into the capabilities. I want to explain to you on a high level how this works, and then if you want to adopt this feature, just a few high-level best practices that I want you all to keep in mind. And at last, I want to have some demos. I'll have a demo as well. All right, so let's go into the why first. Let's imagine for a minute your digital document was a physical one. And oftentimes, when you have a physical document, you're going to store it in filing cabinets. You go to Staples, Office Max, your favorite stationery store, you buy a filing cabinet, you start interacting, putting your docs in, taking your docs out. And over time, the number of documents you might have to work with in your scenario grows for various reasons. Now, you can go to your favorite stationery store, get a bigger one. They'll sell you a 5-tier filing cabinet. But at some point, this keeps happening, and you're not going to be able to get a filing cabinet big enough for all your files, like a single cabinet. You can imagine going to a custom woodmaker, get a cabinet as tall as the ceiling, then you're going to have to get on a ladder, deal with that files. Very analogous to databases scaling up. In fact, what you're more likely to go do is scale out, getting multiple filing cabinets like most sensible folks do, and you're going to put your data in each one of these filing cabinets. Very analogous to databases. Now, you could scale up, as Rashim was mentioning, the scalability of DocumentDB is really good. 24XL, up to the largest instance size, 64 terabytes of data in your cluster. But maybe you want more. Or in any database system, maybe you want more than what a single instance can offer. That's where something like sharding or partitioning or those type of things, type of terms come into play. So that brings us to elastic clusters, which enables you to scale your DocumentDB workloads the same way, allows you to scale out your DocumentDB workloads. 2 points I'd like to call out here that this aims to solve. One, now in addition to millions of reads per second, we're going to be able to handle millions of writes per second. 1 million. That's like billions in a day, trillions in a week. A lot of documents like this can handle. And one of the reasons I like to take a pause here and really talk to you about is this actually, we're really working backwards from our customers. Since 2019, we've had those customers, some of them that were on the board on that wall earlier as well. They used our product, and they felt the need to actually need more scale. So instead of them managing that multiple clusters themselves, this is the type of feature that we built for them and for you as well to be able to adopt so that you can future-proof the scale aspect of your document workloads. All right. So here, I just want to get to one of the points, and I'll show you in my demo as well. But you can see here, this is a CloudWatch dashboard that's actually pointed to our Elastic cluster. To point out what you want to take a look at, 73 million. That is the number of documents being inserted in your cluster per minute. Now, if you're taking a look at this from a second perspective, you'll see you can calculate. Many of you here can calculate that. That's over 1 million documents per second. Really neat stuff. But let's take a look at some of the characteristics of Elastic clusters. I want to be sharing this is a very similar slide to what Rashim was sharing earlier. And that is because Elastic clusters uses a lot of the building blocks that instance-based clusters uses. Right? So here we have fast and scalable. And the biggest change here is that that number 1 million or over millions not only applies to reads, it also applies to writes now. In some cases, actually going back to the first one, in some cases, we could scale as little as minutes. That is, you could double or quadruple your shard count and capacity to handle this much scale in as little as minutes compared to hours, days, or weeks. Third here is IO auto-scaling, so you don't need to provision more networking. We handle that for you as built into the service. And the last point on the very first column here is, it does say most queries complete in milliseconds. Obviously, that depends on your query. You can imagine if you're doing a lot of aggregations, that might take a little longer. But if you're doing a point query, that's going to finish pretty quick. Second column that I already have shown here is fully managed. Like most AWS services, we have some of the aspects of what you would expect in an enterprise workload service that we offer. One of them is highly available. Each shard that we deploy in your Elastic cluster is deployed across multiple AZs for redundancy. So in the event that something goes wrong, we do have a hot backup ready to go. Second, here is snapshot backups. As you would expect with most database products, make that available. We also have durability by default. I'm going to go into that in a bit when I show you the architecture slide and how this works. And then we have some security best defaults, automated patching and monitoring as well. And the last slide, MongoDB API compatible. So today, if you're using a MongoDB workload or you're using DocumentDB and you want to come over to use Elastic clusters, you can continue to use your drivers, your favorite languages, and with little to no change at all. We also aim to support hundreds of APIs, operators, and stages as well. And looking at one future point I'd like to bring up is that as we add more features, we're going to add it to both Elastic clusters and instance-based clusters. Depending on how you want to use it, you could choose depending on the scale requirements of your application. And the last point, most of us do here in AWS, your feedback's the most important piece of it. We're not going to build everything in the world, but we will do our best to work back from your feedback. OK, let's go into how it works. So if you're already using DocumentDB, you could be familiar with a diagram that looks something like this. The key point I'd like to show you here is the separation of compute and storage. And that's really important because you can actually scale that database icon, not the icon itself, but what it represents, the instance, more or less, and you don't have to, and there's no data movement involved. That data movement doesn't exist because it's in the distributed storage volume. which enables me to do stuff like this. I could add an additional instance. I could add an additional instance. All of this, there's no data movement. We are pointed to the same distributed volume. Second thing I'd like to call out is here in terms of the storage volume is that each write that you do, we actually make 6 copies of it, but you only pay for 1. And we do that so that we can have a very highly durable service. Now, this diagram, kind of like imprint it in your mind for a split sec, and then we're going to zoom out. Each one of those clusters, these shards that you see on the very left, from the very bottom, left to right, right to left, is pretty much a cluster from instance-based clusters. What to know here is each one has its own compute capacity, and each one of them has its own writer. And beyond that, each of them has its own set of storage partitions. And this is how we're achieving that petabytes of storage and being able to achieve millions of writes per second. So let's take an example. We have a data set of data. We have an employee data set. Let's say we're trying to put this into Elastic clusters. How does it work? One thing I'd like to highlight here is we have a shard key. This is something that's new. What a shard key does is it tells your system how you want to distribute or partition your data out. So for example, let's say we had the list of documents before. We have a shard key of user ID. It's going to evenly distribute that data across our shards. Let's say I have more data. I want to do something similar. Evenly distributed across the shards. And this is done because Amazon DocumentDB Elastic Clusters uses hash sharding. And this makes it really easy for you to shard your data as opposed to having you select, well, what is the range in which I want my data to be partitioned? Which filing cabinet should I put my files in? Very similar here. Now, similarly, in this diagram, I increased the number of shards. When you increase the number of shards, you don't have to worry about moving your data. We handle this for you. Whether you increase the number of shards or decrease the number of shards, this is handled by this service. All right, so I did mention that you need a shard key to distribute your data. So what makes a good shard key? So if you're going to use this feature, this is one of the things that you do have to think about a little bit in advance. But let's go take a look at the goals. A good shard key will evenly distribute your storage. So that is, you have your data, let's say you have 10 shards and 10 terabytes of data, you're going to have it evenly distributed across your shards. That's 1. Even distribution of your data. 2, even distribution of load. You don't want to have one of your shards to have so many queries coming to that one because it's trying to process that query. So let's take a look at this through the lens of an example. Now, let's say, for example, let's say I chose a shard key state, and I had a user profile. Last time I remember, the state of California had a higher population than the state of Washington. Maybe that'll change in the future. Seattle's a great place. And then, so based on a user profile, you might have many more documents come in that are in the state of California. Now, when this comes into your database, your cluster, as noted by the icon, you might have an uneven distribution of data. Right? Now, over time, this causes a challenge. While each shard can handle 64 terabytes of data on its own, over time, you might run into the same scale challenges because of a poor shard key. And this kind of leads into the second point, uneven load distribution. Let's say we build on top of that. Let's say I find I'm doing a query on having the state of California. When the queries come in, it may have an uneven distribution of load, right, on my database. But in this case, I actually note here that I have both the icons of the shards to be about the same size because with load, it's also possible that while your data is evenly distributed, your query patterns are not. That is, you could have a query pattern that really hits one shard more than the other. So what ends up happening is that one of your shards is going to be running really hot, and we call that a hot shard. And that causes other types of challenges in the long run as well. So when it comes to choosing a shard key, you want to choose something that's high cardinality. That is, unique number of values. Employee ID, customer ID, session ID. IDs in general, I would say, just a rule of thumb, not definite, are a good example. And the next is shard frequency and usage patterns. So you really want to choose a shard key that you know that aligns with your type of queries, as I shown earlier. So that was a little bit on the best practices. We're approaching the demo really soon, I promise y'all. One question I got since this morning from some of our solution specialists pinged me was, well, how is this priced? Right. So one of the things, like a lot of AWS products, no upfront costs, and you only pay for what you use. And it's really easy to understand and predictable pricing. I think that predictable part is actually particularly interesting. I'll let you judge on that. 3 pricing dimensions that we have. 1, compute. For your compute, you get billed per number of vCPUs you use per hour. And this is something you specify and you have full control over. That is the number of shards multiplied by the number of vCPUs you specify per shard. And then that by the number of hours you used in your cluster per month. Very simple, upfront. 2, storage, gigabytes per month. Like most of our database products, you get billed for the amount of storage in gigs per month. Nothing unique here. And last, very similar, backups, gigs per month. All of these dimensions are something that you could easily measure. Again, predictable. All right, so with that, let's get into a demo. Give me one moment here while I boot up my demo environment. Go log back into my machine. Okay. All right. The one time I just pray to the internet gods, please. Okay, give me one moment here. I am going to just make a quick change. All right. Hopefully nothing gets disconnected on me midway. All right, so here I am in my DocumentDB console. Here you can see that I'm in the Ohio region. I'm going to click on Create. And this is going to bring me to our console. I'm going to show you how you can actually create a cluster. I want to make this a little bigger here. The first thing you're going to notice that starting today, instead of creating just an instance-based cluster, you now have the ability to create an elastic cluster. So before, with instance-based clusters, you select the version, the instance class, and the number of instances. But when I select on elastic cluster, there's going to be a few new options. So here I want to call it demo 2, not a particular creative name, but it'll do. Then I can select the shard count and shard capacity. And this is going to be new. The shard count is the number of shards I specified in your elastic cluster. And the second is shard capacity. So I'm just going to leave this one as is. Very similarly, you could select the VPC. DocumentDB is a VPC-only service. That is, if you want to reach DocumentDB from your application, you got to be in the same VPC or reachable to that VPC. I'm going to leave all these capabilities as is. Same with the subnets and security groups. Same thing with instance-based clusters, where you could choose a security group and subnets. And then authentication, I'm just going to put in a password and username. And encryption, so this is to encrypt your data at rest. I'm going to leave it with the default key, and I'm not going to change anything on the maintenance window, all of which these values and variables are the same as instance-based clusters. I'm going to go ahead and click Create Clusters. Now, this is going to take a few moments. While that's going on, I'm going to actually go to a cluster that's already been created called Stretch 5. Now, on this dashboard, let me make this a little bigger. On this cluster, you'll see a dashboard that's very similar to instance-based clusters. However, as noted before, we now have the shard count and shard capacity, right? And you can go down very similar tabs where we have the connectivity and security aspect, and we show you connection string and how you can connect. And we also have the configuration as well. Very similar to instance-based clusters, we have your details here. Now, if you want to change it, let's say you want to scale up, you're ready to go, your application is successful, click on Modify. The first thing that you're going to see on this page is actually the ability to change the shard count. And today, you can increase your shard count up to 32 shards, and you could go up to 64 vCPUs per shard. So that's a lot of compute capacity. In fact, what I was showing you earlier is with these values. So that brings me to the last point here. Let's go into CloudWatch. In fact, what I did right before this presentation started is I just ran a generic workload, just a workload against my cluster. This has that value I was showing you earlier in one of my slides. 74 million inserts are happening this very moment per minute to my cluster. And each one of these values below is pretty much the amount of documents inserted per minute. So you could divide that by 60, you'll get the amounts per second. 3 million each shard summed together, it gets us that pretty much like 80 million docs inserted per minute here. Okay, let's swap back to our slide. One more feature I want to bring up is our free trial. This year, we also launched free trials. So if you haven't used DocumentDB yet, and you like what you saw today, and you really want to give it a try, here you go. Free of charge. Give DocumentDB a try. Gives you 750 hours of an instance, 5 gigs of storage, 30 million IOs, and 5 gigs backup. Pretty much enables you to try most of DocumentDB. There's a QR code there. You can scan it. Also, you could just go to our web page and you can get it. And with that said, that brings us to the end of our presentation. Rashim and I are going to stick around here. One thing that really helps us is to actually complete the survey. And if you have a question that comes up later, I'm going to be at the booth from pretty much 4:30 to 6. Some of my colleagues will be there to answer any questions as well. But please feel free to connect with Rashim and I through LinkedIn or send us a mail if you have any questions. And do complete the session. And that brings us to the end of our session.